All right. So this is going to be a first example of something that I can actually calculate e to the at for. So my goal is to calculate e to the at for a is this matrix here, 0, 1, 0, 0. Now, this matrix is a special one. So I'm going to get a little definition going here. A matrix is called nilpotent. If some power of the matrix is the zero matrix. These don't happen all the time. In fact, they're kind of special, but they present a really easy example for me to start with. So in the example of a nilpotent matrix, this guy here, this is the tape up and forget matrix, right? So I know that this matrix has a squared equals the zero matrix. Because if I tape up and forget twice on a two-dimensional matrix, I'm going to get the zero matrix. We could make the tape up and forget matrix for the three by three tape up and forget matrix. In fact, we'll do that in just a second. So here's what I'm going to do. My goal is to calculate e to the at, so I'm going to say e to the at is the identity plus at plus 1 over 2 factorial a squared t squared plus 1 over 3 factorial a cubed t cubed plus on and on and on, right? And here's the thing. So in this case, I can write out the identity matrix. That looks like 1, 0, 0, 1, right? Then I can write out my A matrix, 0, 1, 0, 0. That's supposed to get multiplied by a scalar t. And then I should have 1 over 2 factorial. A squared is the zero matrix. And I should have a 2 t squared there. And then once I've squared my matrix and got the zero matrix, if I cube it, I'm going to get the zero matrix times A again. That's still going to be zero. In fact, all the rest of these are going to be the zero matrix. And in fact, this one is 2, right? So none of this stuff contributes. And so all I get are these two matrices added together. So I'm going to do my scalar multiplication in there, and then I'm going to add these. So I'm going to get 1, 0, 0, 1 plus 0t, 0, 0. And that's going to give me a matrix that looks like 1, 1 with a 0 in the bottom left and a t in the top right. This is e to the 0, 1, 0, 0 t. And that's as simple as that is. Nilpotent matrices are real chill. So let's do this same thought. So let's calculate e to the at for a is the 3 by 3 tape up and forget matrix. So putting zeros down the diagonal, zeros down here. I know I've got 1, 1 here, so that's y ends up in the x slot, z ends up in the y slot, and the z slot ends up being 0. So here's my tape up and forget matrix. And then I know about this one that a squared is 0, 0, 1, 0, 0, 0, 0, 0, 0, right? That's once I've tape up and forgot twice, the z ends up in the x coordinate, everything else is 0. And a cubed is in fact the 0 matrix. So if I'm calculating e to the at, this is going to be the identity matrix plus the matrix A, whoops, times t plus 1 over 2 factorial a squared times t squared plus all of these guys are the zero matrix. So I'm just going to suppress all those. And then I'm just going to do this addition. So I'm going to get, let's see, I've got zeros in the bottom left. I've got ones down the diagonal. I've got t's on the super diagonal. and I've got a t squared over 2. Oops. T squared over 2 in that top right corner. And that's it. Nilpotent matrices are really interesting. There's not a ton of them. There's a few. They're kind of a special case. They don't all have to be full of zeros. So it is pretty possible to make a nilpotent matrix that has no zero entries, in fact. Maybe give it a shot. It's kind of a cool trick to find one. All right. That's it for this video. I will catch you guys on the next one.